First of all, what kinds of things stand as an identifier? Certainly if I asked you, what would you tell somebody if you wanted to distinguish yourself from other people? First thing I think you would say is, oh, I'd tell them my name. My name is Bob Boyko. That distinguishes me from all the other people around me. Or does it? The problem with names is that they aren't that great as identifiers. In fact, when I joined Facebook, the first person who found me and tried to friend me, and in fact I think I am friends with this person, is another guy named Bob Boyko, right? So the other Bob Boyko on Facebook friended me, and so it's not a unique name. Even though you might think that's a unique name, names are not unique. But they are what we generally use, and to a first approximation they're unique, but a first approximation is not what we need on the net. An absolute identifier is what we need on the net. Okay, so my personal name is definitely not unique, but my username, like the username I choose on Facebook or the username I choose on any of the other sites that I visit on the net, that is unique. It's enforced. It's made to be unique by the people who are on the site. If somebody else already has that name, as you well know, like if you ever try to get a Google, a Gmail email address, you know that your name, you have to be number 5,672 to get anything that's anywhere near your name. That's because they enforce uniqueness. Why do they enforce uniqueness? Because they're using that username as an identifier. Your personal name is not a good identifier because a lot of people share that name and you can't do anything about that. Your username on computers, however, is enforced to be unique, and we'll talk about how that enforcement happens a little bit later. So in general, though, our identifiers tend not to be names, they tend to be numbers. Your social security number, your telephone number, your passport number, your driver's license number, your credit card numbers, all of those numbers are unique identifiers, and it's really pretty easy to keep them unique because you can always just choose another number. Right? And also we don't associate those numbers personally to ourselves. We wouldn't give somebody, if they say, oh, I'm Joe, who are you? You might not say, oh, I'm 957-643 on 3026. You're not going to do that. So it's not important for that number to be any number or any other number, and so numbers very often and very easily serve as unique identifiers because there's lots and lots of them. We can always have one number higher, and because people don't put anything into them that would require them to be non-unique or apply to more than one person. So we have names as identifiers used only really in this username idea. We have numbers as identifiers used all over the place, lots and lots of numbers as identifiers. And then we have addresses as identifiers. The idea of an address, and let's start with a locational address. I say my address is 543, that's my house number. 27th Avenue, that's my street number. Seattle, that's my city. Washington, that's my state. 98764, notice a number, uniquely defining a region in space. United States of America, North America, Earth, solar system, blah, blah, blah. Notice what I'm doing there. There's plenty of house numbers that are the same as my house number, but no two house numbers on that same street. There are plenty of streets that are the same street as mine, but no two streets in that city or in that zip code, and then on and on and on. So we're using the fact that we're using a combination of different parts to enforce the uniqueness. And especially since we have a zip code in there or a postal code wherever you are in the world, the postal code was designed specifically to get rid of any of the ambiguity. And if there happens to be 2/3 streets in the same city, then the postal code will disambiguate. Disambiguate meaning show you the difference between one and the other and make it unique. So when we disambiguate, we create uniqueness, and that's what a postal code is there to do. But the basic idea of why an address is unique is because it's nested. It's a hierarchy. It's one location inside a wider location inside a wider location, and it's less and less likely that you'll have the same house number if you nest it inside of those larger and larger locations. If I just said my address is 547, well, that could be anywhere in the world. But 547 23rd Street, that narrows it down. Seattle narrows it down even more. Washington narrows it down even more. United States, et cetera, until it is pretty much guaranteed to be unique. So the idea of address originally was a geographic address. We could have latitude and longitude, and that would really nail it down because there's no two places on the planet that have the same latitude and longitude, so that's unique in that sense. But in general, or not in general, but on the web, we have other ways of having addresses, and specifically two kinds of addresses on the web that are also unique. Web addresses, sometimes called URLs, and also email addresses. So the email address and the web address actually work in a very similar way to the geographic address. So a URL might be ischool.washington.edu/index.html. Well, there's lots of index.htmls on the web. They're all over the place. That's a very common name for a web page. But if you add all of those other modifiers, and those modifiers are loosely in hierarchical order from the edu, which is the most general. Edu means educational institution. That's all the educational institutions in the world, so we've narrowed it down. Then we have Washington, which narrows it down even further. That's the institution inside the educational institutions, University of Washington. Then we have iSchool, which narrows it down even further. And that uniqueness is then comes about from the exact same way that the uniqueness of your physical address comes about, by having a set of qualifiers or a set of more and more general terms that assure that something that is non-unique, like the word index.html, which happens all over the web, is made unique by all those other parts that are tacked onto it. We'll get to a bigger issue in a moment about how do we know that there isn't another ischool.washington.edu somewhere around, right? How can we be sure that that's unique? Okay, so before we do that, however, let me find my way back to my slides here. We also have email addresses. So when I'm like bboyko@uw.edu, we have that same idea. There may be lots of bboykos. There may be a bboyko on Hotmail. There may be a bboyko on Gmail. There may be a bboyko on AOL. But there's no more than one bboyko at uw.edu. uw.edu, right? That's another example of that hierarchy of more and more specifics that allow us to say that the bboyko I'm talking about is none of the other bboykos anywhere else on the web. It's that particular one. Okay, so these addresses are made unique. All three of these addresses are made unique by having this hierarchy of generality, more and more general. And when you put all of them together, it's made impossible for there to be more than one of those. And again, we'll come back to why it's impossible for more than one of them in just a moment. Okay, so those are the kinds of identifiers. We have names, we have numbers, and we have addresses. Those are the big kinds of identifiers that we use. And in all cases, as I said before, the identifier is there to say this is authoritatively this object, this person, and no other. So we've only been talking about identifiers for people, but there could be lots of identifiers for other things. For example, every time you look on the back of some kind of piece of machinery, there's a serial number. What's the serial number? The serial number is the way of uniquely identifying that object, that machine, that camera, or whatever it is, as being that one and none other. So we always want to have a way of saying it's that one and none other.